Okay, so as we saw in the last video, when these limits are plus or minus infinity, we have what's called a vertical asymptote of the function. Right, so just a formal definition here real quick. Um, just sort of reiterating what we said, which is that if any of these limits, right, it can be a two-sided limit like these first two here, it can be limit from the right or from the left. If we get plus or minus infinity for either of those, that means that the function has an asymptote there, because it means that the function is getting closer and closer to this vertical line x equals a, but it's not crossing it. It's just sort of becoming parallel to it, almost. And if that's happening, that means we have to have a vertical asymptote. Okay, so how do we find vertical asymptotes? Well, another way to ask that question is, how do we compute one of these limits if the limit's going to plus or minus infinity? How do we do this? Well, the idea is we want to check, do we have something that's not zero divided by zero? If we're in that sort of situation, then we just need to start checking the signs of things, like positive or negative. So let's look at these two examples here, right? So this function here is not defined at x equals 4, right, because of the denominator. If we plug in x equals 4, we get 12 over 0. So this isn't one of our 0 over 0 situations where we might be able to do some kind of simplification. So something else is going on here. Let's find out what it is. All right? So let's start with this first one here. When we're computing values, when we're trying to compute this limit from the right, so for this first one here, right, for this guy, we're trying to plug in values essentially that are bigger than 4. Okay, so here, we can kind of already tell. So actually, maybe even before doing this, before looking at that, let's just sort of look at this here. So plug in x equals 4. I know I just said this, but let's reiterate it, because this is really what's going to set us on this course. If we plug in x equals 4, we get 12 over 0. Okay, so since this is not 0, since the numerator is not 0, but the denominator is, this is what should point us in the direction of plus or minus infinity, right? So limits are going to be plus or minus infinity, right? I guess I should specify here, these are for one-sided limits. Right? The two-sided one might not exist if these don't match. Okay, so again, now for this guy, what we're doing is, heck, we deleted it. So for this thing, we use values bigger than 4. So let's say greater than, well, not greater than or equal to, greater than 4. Right, so what's the point of that? Is, well, we need to look at the signs of this fraction. We need to know, are we going to positive infinity or negative infinity? So the top here, this is positive for x greater than 4, right? If we put in numbers that are bigger than 4, 3 times 4 is positive. Down here, this is also positive for values of x bigger than 4. So, since the numerator and the denominator are both positive, so because numerator and denominator are both positive, then think of, what would the sign of a fraction with a positive numerator and a positive denominator be? Would be positive overall. So this limit here must be infinity. So right away, this already tells us that this function 3x divided by x minus 4 has a vertical asymptote at x equals 4. Right, so it already tells us that. But let's look at the other one just to see a little bit of a difference. Okay. So for the limit from the left, I'm going to copy this. Change that to a minus. So for this one, we're going to do the same thing. We're going to, this time though, use x less than 4. Right? Since we're coming from the left, we want to start out smaller than 4 and get larger. So let's do that. Right? So if we look at this, 3x over x minus 4, again, this is still positive for x less than 4. Now I should say, when we're doing these, we're trying to look at values close to 4, right? Because like -2 is less than 4, and that would make the top negative, of course. So anytime we're kind of looking for limits going to a specific number, we're always trying to think of numbers that are like really close to that. So here we're looking at numbers really close to 4. So that's implicit all the time here. So, we could say here, this should be like close to 4. Right? And that becomes more important for later functions where like the denominator has multiple places where it's 0. Okay. So now back to this. So the top is positive. The bottom, on the other hand, this is negative for x less than 4. Right? So since this is negative, this fraction that has a positive top and a negative denominator, or positive top, negative bottom, overall that would give us a negative fraction. So since we know this has to be going to plus or minus infinity, and now we know that this fraction is negative when we get close to x equals 4, this tells us that this limit has to be negative infinity. Right? And again, this tells us, if we did this one first, this would also tell us that this function has a vertical asymptote at x equals 4. Right? So 3x over x minus 4 has a vertical asymptote at x equals 4. Right? And again, we don't have to do both limits to show that it has a vertical asymptote. We just need one of the two. Right? By the way, what would the limit be, just the two-sided limit, as we approach 4 for this one? What would that be? Hopefully you can see that that should be, doesn't exist. Because these two are different, the overall limit can't exist. Right, so hopefully that gives you a better idea of how we do these sorts of limits. See you in the next video.